what on earth is going on with 29P? So, for those of you who don't know, 29P is a comet in our solar system. And a part of my PhD is researching the rotational period of 29P. And as you'll come to see over the next 10 minutes, I've made a massive mistake. Okay? I should have left it alone. Right. So, that is terrible. So, what, when, who, where, why. Okay, these are the main details. Okay. Now, this is gutting, because I was going to count to 3 and get you all to try and pronounce this, right? But you can't read the first word. We're going to do it anyway, okay? So I'm going to go 3, 2, 1, go. And then when everybody to shout out the name of that comet. If you can't see it, come closer, all right? Age is an issue, I get it, right? 3, 2, 1, go. That's why I call it 29P, okay? Right? I've been studying it for a year and I'm still too scared to say the name out loud, right? When, in 1927, this comet was captured going incredibly bright to the human eye. It's very, very rare, and it's one of the things we'll discuss as we go on. Who? Arnold and Arno Arthur. I'm not saying their surnames, but they were the ones who observed this comet for the first time in Hamburg Observatory. And why? Well, this is why we're here. We're going to get into it. It's good. Right, so this is our solar system. I think on every presentation I've done, there's a solar system slide, right? And Comet 29P is just here, behind Jupiter, just over 6 AU, that's astronomical units. So if you don't know, the Earth is 1 AU from the Sun, that's how we define an astronomical unit. This is just over 6, it's 6.22, which is just past what we call the sublimation zone. You need to remember that because it's going to come in handy later. And if you're not aware, sublimation is the process of going directly from a solid to a gas, bypassing the liquid phase. Okay? Happens under different pressures, temperatures, etc. than you'd expect here on Earth. Why is 29P so unique? Right. So its classification is a centaur, which is a transitional object somewhere between a comet and an asteroid. So they're more rare than comets and more rare than asteroids, right? So already we're off to a flyer, right? Its diameter is around 60 kilometers. And if you're not versed in comets, that's absolutely massive. It's one of the biggest comets we know about, right? Any bigger, you'd think it was a moon. It's massive. Its rotation period is much longer than any other comets. Almost every other comet we know of has lower than a 24-hour rotation period. So like a day on Earth, a day on most comets is under 24 hours. On this comet, it's almost 60 days. Its eccentricity, so that is the shape of its orbit. A lower eccentricity is closer to circle, right? A higher, up to 1, that would be a total oblong, right? That's as eccentric as the circle can go, right? So it has a more circular orbit than Earth. That's pretty rare because if you think of any famous comet that you know, they fly close to the sun, right? They have an elongated orbit, 78-year orbit or whatever for Halley's Comet. That's what they do. That's typical. This is just well out of the ordinary. Now the albedo, pretty common for a comet, but I really love the word albedo, so I chucked it in there because it's my presentation. And the year length is 14.9 Earth years. Okay? Now, I know what you're thinking, right? Tony, we get it. It's unique. Talk over, right? He was a surprise guy. Next one. But wait, there's more, right? What makes 29P so incredibly unique, and I'm not very good at maths, but I once classified it as more unique than life on Earth. I would not stand behind that statement at all. Outbursts, right? So if anybody doesn't know what an outburst is, which I didn't before I heard of 29P, this is an outgassing event where in the space of minutes, hours, or sometimes over the course of a day or two, a comet will expel massive amounts of dust and gas, and typically we would see that in the form of a comet developing a coma, right? So it comes in, passes the sublimation zone, right? Starts blasting away all the ice, right? That is an outgassing event, but it's one that's very typical for every comet. Now, this doesn't come in past the sublimation zone because, as you'll recall, it's past the sublimation zone and it's almost a circular orbit. Yet, it's more active than any single comet in our solar system. It is the most active of all the active comets. And scientists don't know why, because it never crosses that zone, right? Frequency varies, but typically 7 per year. And each event can increase the brightness of the comet by hundreds of times. Now, that might seem small when you think of a comet because you can barely see them, so hundreds of times is nothing, is still barely above nothing. But if you can imagine even the moon being 10 times brighter, it would blind us all, right? We would all be blinded by a moon that was 10. This is hundreds of times brighter. Hundreds and hundreds of times brighter. 7 times a year, all the time. Never loses mass, because it never blows the dust far enough away to escape its own gravity, because it's so bloody big. So it coalesces back together and does it again, and again, and again. Over and over, all year round, right? Now, before we go any further, I just want to introduce you to how we measure brightness. It's in magnitude. If you're not aware of magnitude, it's the most fucking ridiculous scale that has ever been invented, ever. And I'll tell you why. This is from Britannia now, just so you know it's not a made-up definition. Magnitude, in astronomy, a measure of the brightness of a star or other celestial body. The brighter the object, the lower the number assigned. So the brighter it is, the lower the number. So any graph you see with magnitude has the x-axis, no, the y-axis, flipped vertically, and the numbers go the wrong way. This is because, in ancient times, people used to say, they had a by-eye magnitude scale that was split into 5 or 6, depending on whether you could see it with the naked eye, right? And when we tried to classify that, instead of going, guys, that was stupid, they were people who knew, very little, we should create a new system. They went, no, what we'll do is we'll keep the 5 or 6, but we'll run them down from 6 down to 0, right? And each step will be 2.5 times brighter than the last, not 10, not 1, right? 2.5. So that after 5 steps, it's exactly 100 times brighter, which is great, right, for 5. But if it's 6 steps, it's 250 times brighter, which makes no sense, right? So anyway, as we developed better technology, we could see more and more and more and more stars and celestial bodies. So what did the bright people do? They didn't make a new system. They added negative numbers and they took the positive up to 20. So now we have a scale of magnitude with the dimmest things that we can see at 20 and the brightest things we can see are -5. Yeah? And if that's not stupid, I don't know what is. It just goes to show that, even people who are doing this work, right, everyone gets stuck in their ways, nobody's perfect. And God knows the amount of times that I've read a magnitude graph wrong, yeah, because I'm expecting it to go up, and I've been doing it a year. Right. So, obviously you can't see the writing again, so I'll read it out for you. There are 2 proposed physical mechanisms for these outgassing events. One, the beautifully named amorphous ice to crystalline ice conversion. The other one is cryovolcanism, which also sounds pretty cool. And they're both effectively the same thing, but they start in different ways. So amorphous ice to crystalline conversion, they would state that being just past the sublimation zone, but on a very circular orbit, allows it to warm up very, very slowly. As the ice underneath the surface warms up, crystals form, and as the crystals become more uniform, the bubbles of gas that were trapped inside the old shitty crystals is released. And when that gas is too much, it blows. So it's exactly the same, but the other way around. The cryovolcanism would suggest the thermal warming in the core is heating the subsurface ice, it's rearranging, and it's blowing. Now it's very important, this next bit. That one, right? Because it's outside, so the sublimation zone applies only to water. But carbon compounds, so carbon monoxide, carbon dioxide, they sublimate at much lower temperatures. Okay, so that's why we're able to view this behavior far outside of the sublimation zone. So, now that I've told you just about everything that's exciting, I bet you're dying to see this incredible, it's just like unique, one-of-a-kind object, right? This is one of the issues. is even with the best technology, these are the pictures we get, right? So we can infer things based on brightness, which is a lot of what we do, but we struggle very greatly to see the morphology of the comet. So when we make models, we usually assume that it's a perfect sphere, etc. But I'll get into that now because new information suggests that it's not, and it might have made my research a million times harder. So this is a light curve with the axes wonderfully obstructed. As you can see, the higher number is on the bottom, the lower number is at the top. Very confusing. These are different filters that we observe 29p with, right? Some pick up different elements. So for instance, these ones here, they're picking up carbon monoxide, carbon dioxide. These ones here, they're picking up infrared. So it's the infrared reflection of our sun from the dust when it explodes or outgasses. This is 8 years, so this was my master's research. This is 8 years of outbursts every year, all the time. And obviously when you see a difference of 4 or 5, that's 100 times brighter. Yeah, and just regularly, all the time. And in between the 100 times brighter, there's 2.5 times brighter, there's 6 times brighter, over and over and over again. But the big one's about 7 times a year, 100 times brighter. This one in particular, this was in 2021, again you can't see, but this was around 400 times brighter. A single outburst over 2 days, this was seen by eye. So a comet that you would never have a chance of seeing was twinkling for 2 days as it released all this gas. Recent news. JWST. Recent imaging suggests discrete events and a potentially bilobal structure. So remember what I said earlier, when I said when we make models, we assume everything's a perfect sphere. Well, now we might have just been told it's not a perfect sphere. In fact, it might be made up of 2 bodies that have crashed and coalesced together. Well, if you can imagine trying to work out the rotation period on a single sphere, easy, right? As you add another weight to it and it starts tumbling, I mean, it's not just, I mean, it's almost impossible, right? So I might have left myself with quite an impact. It's lucky that a lot of my research is in outreach, because I don't think the 29p research is going to go very far. As mentioned, catastrophic implications for the rotation period. So that's me up a creek. Still no definitive outburst mechanism. Funny story though, the 2 proposed mechanisms. So what you might not know is in astronomy, there's a huge amateur movement. And typically, because to be a good amateur, you need reasonable equipment that costs lots of money, there's a subsection of society, and you know, it's typically middle-aged to old, successful white males, right? And the longer you've been in the amateur game, the older you are. And I was at a recent event in Edinburgh where the oldest white people I've ever seen were calling each other out over what the physical mechanism is. And the funniest thing is that neither physical mechanism rules out the other. And I thought it was gonna get WWE style, and they were gonna be, you know, suplexes and broken bones, right? But we avoided it. So, when I asked you earlier, what on earth is going on with 29p? The answer is, I don't know. That's science, baby. Anyway, thank you very much for listening to my talk. A panel will sort out the quiz now. You've been wonderful. Thank you, guys. Oh, before... You can keep clapping if you want. This is the good part. So embarrassing. Has anyone got any... I don't usually take questions, but I'd look like a right arsehole if I didn't take questions on my research subject.
Why are you thinking 29p?
Sorry?
Why is it called 29p?
So basically, I can't remember the lettering assignment, which I'll be more than happy to tell you, but it's something to do with the telescope, and that was the 29th that was discovered within that system or that, yeah? But I'm more than happy to get a definitive answer for next time, but it'll basically be the 29th in that catalogue, yeah? But I can't remember what the P is for, if I'm honest. And yeah, once you get deep into sort of age of data sets, the P becomes unimportant. This is why I've never said the real name, I just call it 29p and I crack on. But yeah, so I will get a better answer, all right?
Cheers.
Any others? No, I think we're good. One more second. Sweet. Okay. Thank you very much.